Hello students, we are going to be going through 3 of the problems for assignment 91, the practice problems. For honors I will do 4 problems. So after practice problem number 7, those in the on-level classes can go ahead and stop the video. If you are in honors, you will probably want to watch me also go through problem number 8 as well. So let's get started with number 3. So number 3, hopefully you've already done 1 and 2. Those were, I think, not too difficult. 3 of those first 4, I think, were the most difficult, and I put the picture from the book on the screen showing the barn door, and then I redrew the barn door so you could see it a little bit more clearly. You're asked to find the measure of angle TQR. And in the given information in your book, you were already told that the measure of angle PTQ is 67, so I have filled that in. Okay, so let's talk about what we know to try and find the measure of angle TQR, and that is the angle we want is this one right here. That's our question mark, is that one. So how I could find that angle? Well, there's a few things I know. I know that PQR, I know that that whole thing is 90 because I was told it's a rectangle, so I know that it has to add up to 90. And I also know that triangle PTQ is an isosceles triangle. And the reason I know that is these diagonals, PR and SQ. Diagonals on a rectangle both bisect each other and are congruent. So since they're equal to each other and they bisect each other, that means that PT has to be congruent to TQ. And if that's true, then we have an isosceles triangle. So that's going to make it a lot easier. So what I can find is this angle and this angle. And so once I know angle TPQ and angle TQP, I can then use that information to get TQR. Okay, so this is what it's going to look like. We know that a triangle adds up to 180. So 180 minus 67, okay, the 67 for angle PTQ, equals 113. So what that means is this angle right here and this angle right here have to add up to 113 because it's isosceles. So those are the base angles and they have to be equal to each other. So if I just divide by 2, I get 56.5. So that means this angle here, TPQ, is 56.5 and PQT is 56.5. But I still don't know this angle here. This is the one I'm searching for. So I know that the measure of angle PQR, the big one, equals the measure of angle PQT, which I just solved, plus the measure of angle TQR, the one I'm trying to solve. Well, PQR is the right angle, so that's 90. And I just determined that PQT is 56.5. Oops. 56.5. And so then that leaves my only unknown, the measure of angle TQR. So if I subtract 56.5 from both sides, then I'm going to get that the measure of angle TQR is 33.5. Okay, number 5. Number 5, you're given this rectangle. I cut and pasted the picture here. You are given a rectangle, DEFG. You're told if FD equals 3x minus 7, so FD is a diagonal, and EG equals x plus 5 to solve for EG. Well, we were taught this unit that the diagonals of a rectangle are congruent, which means their measures are equal to each other. So that means FD equals EG. So I substitute with the information I have and just solve. So I'll subtract x from both sides, and that will give me 2x minus 7 equals 5. Next, I'll add 7 to both sides, opposite sides of the equal sign. So it gives me 2x equals 12. Finally, I'll divide by 2, so x equals 6. But what I'm asked to find is EG, not x. So I need to plug that back in. So I was told that EG equals x plus 5. So if EG equals 6, right, if x equals 6, then that means EG equals 11. And then the final one I'm going to do for the on-level classes is go through the proof that you were asked to do. There was a 2-column proof. All right. If ABDE is a rectangle, so we know that it's a rectangle. It's not something we have to prove. We already know that it's a rectangle. So I'm going to mark one of the angles as a right angle, and we know if one angle in a parallelogram is a right angle, then all 4 are. So all 4 angles are right. If ABDE is a rectangle and BC is congruent to DC, that's already been marked, we need to prove that AC equals EC. So AC, this piece of a triangle, and EC, a piece of a couple triangles, we want to prove that they're congruent. So we always start with our given. So we're going to say ABDE is a rectangle. And then we also want to indicate that BC is congruent to DC. And this is all from the given. Okay, next I can say that ABDE is a parallelogram. And I'm going to just draw the symbol for a parallelogram. And that is based on the definition of a rectangle, because the definition of a rectangle tells us that rectangles are parallelograms. So because it's a parallelogram, then I can say that AB is congruent to DE. Okay, so let me show you over here what I mean. AB, the top, is congruent to the bottom. And the reason I can say that is because opposite sides on a parallelogram are congruent. Okay? So we know that to be true for parallelograms. So hopefully what you can see, what I'm trying to do here is I want to prove that this triangle ABC is congruent to this triangle over here, EDC, because if they're congruent, then AC would have to be congruent to EC by CPCTC. So right now I have 2 sides being congruent, so I'm on the right track. Next, I'm going to say that angle B is congruent to angle D. Whoops, I'm sorry, I need to say one more thing first. I forgot about that. Angle B, while that is true, I need to make another statement first. Angle B and angle D are right angles. Okay, and that's also from the definition of a rectangle, that all 4 angles are going to be right angles. Now I can say that angle B is congruent to angle D, and the reason for that is all right angles are congruent, right? If they're all right angles, we know they have the same measure, they have the same shape, so they have to be congruent. So I have now proven that angle is congruent to that angle. So I now have SAS for my triangles, side angle side. So I can say that triangle ABC is congruent to triangle EDC, and that's by side angle side, SAS. And so because those two triangles are congruent, then AC is going to be congruent to EC. And that is back based on CP, CT, C. Okay? All right. On-level students, you can go ahead and stop now. Honors, you will probably want to stay and watch as I go through number 8. All right, here we go with number 8. You were given, let's see, you're given 4 points, W, X, Y, and Z. And you can see I've already plotted them on the graph. W is at -4, 3, X at 1, 5, Y at 3, 1, and Z at -2, -2. And you're asked to prove or determine whether the quadrilateral is actually a rectangle. And in this one you were asked to use the slope formula to determine that. Now we can see visually by graphing it that that does not look like a rectangle because it does not look like two of the sides are parallel. And since we're going to use the slope formula, I'm going to pick the top and the bottom, WX and ZY, and compare their slopes first because visually it does not appear that their slopes are the same. But you must prove it using the formula algebraically, so you cannot just make that statement, okay? So let's start by doing the slope of WX. So I'm going to do the slope of line WX, and that will be the change in Y over the change in X. Oops, I'm sorry, that was +3 there. So that's going to give us -2 over -5, which will simplify to 2/5 because we have two negatives. Okay, so that's the slope of the top line. Now the slope of the bottom line, the slope of ZY, we're going to take change in Y over change in X, and that's going to give us -3 divided by -5, which gives us +3/5. So because the slope of WX does not equal the slope of ZY, we can say that no, it is not a rectangle because opposite sides are not parallel. And we know that because their slopes aren't parallel. So I don't even have to check WZ and XY. Even if their slopes were parallel, it would not matter because both pairs of opposite sides have to have parallel slope. On number 9, the one that you're going to do on your own, it's based on distance formula. Make sure you do the distance formula not just for the 4 sides, because the 4 opposite sides being congruent just makes it a parallelogram. Then you'll also need to check the distance formula on the diagonals, because for the diagonals to be congruent or equal in measure, that's what will make it a rectangle. See you in class. Bye.